So given the function y equals x minus 1 squared minus 4 and its graph to the right, part A, use the graph to write down the coordinates of the x-intercept and the y-intercept. So if we're just looking at the graph, you just have to identify. Here are your x-intercepts here, and we write those as coordinate points. So the first one being -1, 0, and your next one being 3, 0. And the y-intercept, I'll put that in a different color. Here's your y-intercept, and it is 0, -3. That's easy because you're just looking at the graph, right?
Yes.
So letter B says verify algebraically by using substitution that your answers are correct. So this is from the original equation. We have to substitute in our x and y values just to make sure that the equation holds true. So if I write y equals x minus 1 squared minus 4, that's the original equation, I'll first substitute in my x-intercept. So for y, I put in 0, and I'm just checking to make sure, does that equal, that's a question mark, does that equal? -1 minus 1 squared minus 4. So 0 equals, this is -2 squared minus 4. Does 0 equal 4 minus 4? And yes, it does. 0 equals 0. We're happy. We have to do that for each of them. So go ahead and try to do that for each of them on your own. When you verify points, that you always start your first step by writing the equation. Your next step would be substitution. And you never cross this equal sign here. You're just checking to make sure the left-hand side equals the right-hand side. So your very last step would be 0 equals 0, and then the equation's verified. So we verified for all the points. Part C says show algebraically that the point 2, -3 is on the curve. So right now take a moment and do that yourself. Same process again, you just write your formula, do the substitution, and balance your equation, never crossing your equal sign to make sure that you have in the end -3 equals -3, and then the point is verified. All right, for the next problem, we're given the function y equals x squared plus 7x. I'm guessing that's going to be a minus 18. Yeah. I know that because, oh, my y-intercept is negative over here. And the graph to the right. Part A says, using the graph, write down the coordinates of the x-intercept and y-intercept, verify your results, and then determine again if another point holds true for the function. So we're following the same process now with a new equation.
Why is on this graph the y-intercept is not the y-intercept, but it goes down to -3 instead of -18?
You mean the minimum point of the?
Yeah.
Okay, because the y-intercept is just where it touches the y-axis,
Sorry.
and this point here, your minimum is actually your vertex. But that's a good question. So go ahead and try that. All right, here's all the values as you substitute in for your equation. Last sentence, again, should be 0 equals 0, just confirming or verifying your results. Part C, this notation is a little bit different, but that's just another way. It's called function notation. It's just another way to write a coordinate point. This is like thinking of f of x. So this means the same thing as the coordinate point -10, 12. And we're just trying to see, does -10, 12 actually fall on the curve? So go ahead and try to substitute those points in, and we'll check back. And there we have it. Substitute, verify, and that just means that the point here, -10, 12, way up here, somewhere will fall along this curve. There's our point. -10, 12. Yay. All right, number 3. Find the x and y-intercepts for the following equations, and then check your work with your GDC. Now we don't have something to look at on the graph. We have to actually substitute in our values. So let's start first with the easy one, which is always the y-intercept. The reason why that one's easy is that is when x is equal to 0. So we substitute 0 into our equation. We have y equals, instead of x, I write 0 minus 1 squared minus 4. Negative 1 squared minus 4. And we get negative 3. You always write this as a coordinate point. So 0, negative 3, that's your y-intercept. To find your x-intercept, it can be a little tricky. Your x-intercept is always when y is equal to 0. So we'll set y equal to 0. We have the equation 0 equals x minus 1 squared minus 4. We're solving for x. We want to isolate x on one side of the equation. So we can add 4 here, add 4 here. Now we have 4 equals x minus 1 squared. Take the square root. Don't be fooled. It could be a plus or minus 4. That's the tricky part. And if you think about it, it's a quadratic equation. This is opening up. We have a vertex at 1, negative 4. So 1, negative 4 somewhere down here. And it's opening up. So it's going to have 2 x-intercepts. So now to write 2 equations out so that we can solve for 2 x-intercepts. Yes, hello.
Wouldn't it be plus or minus 2, not plus or minus 4?
Yes, good call. That's plus or minus 2. It's the square root. Whew. Lucky you are here. We would have been way messed up. Okay, so now we have 2 equals x minus 1, or negative 2 equals x minus 1. Now solve for x. This one gives us 3, plus 1 here, plus 1, and this one gives us negative 1. Oops, I just wrote 3 equals 3. Again, you want to write this as a coordinate point. So your coordinate point would be 3, comma 0, and negative 1, comma 0. So there's everything that they're looking for in this problem. Now we'll attempt the next one. All right, start off with the easy one, and that's finding the y-intercept. We set x equal to 0. So we have y equals 6 times 0 squared minus 0 minus 2. Easy peasy, lemon squeezy. Done? All right, other one's a little bit trickier. We have to set y equal to 0 to find our x-intercepts. Now we have 0 equals 6x.
Oh, you always do y equals to 0 to
Where?
find out your x.
Correct. You always set y equal to 0 to find your x-intercepts.
Oh,
This one for me is not easy to factor, so I would use the quadratic formula. There once was a negative boy who couldn't decide yes or no whether he had a radical party, but the boy was a square and missed out on 4 awesome chicks, and the party was all over at 2 a.m.
Oh my goodness.
Are you kidding me? That's how long on you do the song.
B plus or minus square root of b squared minus 4c all over 2a.
Oh, that sounds cute too. Okay, so B is, I would, negative 1, put in negative 1 squared minus 4 times 6 and negative 2 all over 2 times 6. Now it's just all this messy operations, order of operations. This is 1 plus or minus the square root of 1 plus 24 times 2, 48, all over 12. Almost done. 1 plus or minus root 49, all over 12. Oh, I like that. I know the root of 49.
Wait, how'd you get to 49 if you had 48?
At 1 plus 48.
Got it.
This is 1 plus or minus 7 over 12. So that means I have two solutions. One solution, x is 1 minus 7 over 12, and the other solution is 1 plus 7 over 12.
And that's all.
Of course, we should simplify that, right? This 1 minus, that's negative 6 twelfths, which is negative 1/2. And this one is
No more space.
8 twelfths, which is 2/3. And like before, we write as a coordinate point and then call it quits. Negative 1/2, 0, 2/3, 0. Sorry, you ran out of space.